Today I'm going to explain what happened to this part. This part has been cut by a 5-axis machine, and we have two major problems. The first one is, do you see the lines here, the arc, the marking here, right? So this is a very clear marking. Why? So now I'm going to explain why. And this is a two-part that used to cut, okay, not the original one. I changed the pitching to 2 mm so that it's easier for you to see and then to explain. The original pitching is 0.02, very small. Yeah. Why? Let's do a simulations and you understand why. Right, so we are starting from this section here, okay, and it cut radially in a radial manner, clockwise direction. So you will start at this section and end at the same place also after finish, okay. And this is not a good thing. This is the place, right? You start and end at this same, almost the same section, okay, this area, and this is not a good thing, because any place that you cut twice, the two parts twice, you have marking, okay. Right, then look at the marking here, this area cut twice. That explains why you have this marking. So how to solve this? Don't use this kind of radial cut, okay. You cannot solve it. This is a limitation for the radial cut. Next, I will explain why the surface texture over this area here, especially, right, is very bad. You can see some steps, right? Very bad. Why? Let's look at the Cimatron file, and this is the original two-part. I'm going to show you the navigator, and let's look at the points, the two-part point, right? And you can see that some area the point-to-point distance is very small, some areas very big, so it is not uniform, especially the distance over here. I can measure and see what's distance, so it is around 0.308, right? How about this side? The other side is 0.155, so it's a huge difference, okay. So the big area will give you will result in the surface texture problems, okay. That's the reason. Because the reason is because the point-to-point is not uniform. The distance is not uniform, and some areas big. And why point-to-point distance? When you have big point-to-point distance, the result is bad. Now I'm going to explain why. Let me do it again here. Right. Let's say I have 2 points here, from here, this point to this point, right? We are cutting these directions, right? Point to point. So if we cut this part by 3 axes, of course the two paths between the 2 points will be straight. It will be straight for sure. okay, and and the result for 3 axis will much better from the 4-5 axis for sure. For 4-5 axis, the actual 2 part along between these 2 points is not actually what you see in Cimatron. It is not straight. It actually curves. It actually curves. It actually curves either this way or this way. That explains the quality why is bad, worse than the 3 axis. Okay, if the point distance point between 2 distance is big. This is because of the 4 axis and 5 axis two angle change, 2 vector change. Yeah. Okay. So how to solve this kind of problem? Of course, in 4-5 axis we can control, especially in 4-5 axis, we can control the point-to-point distance and make it smaller, like adding extra point at between. Okay. So if you have extra point, even though the actual part is not straight between point, right? Compared to you just have a 2 point, right? So if you have more point, the part can cut close to the more accurate to the surface, and the result will be, of course, much more smoother, better. Okay, smoother and good. Okay, so for the radial cut, I don't like it. Okay, so this kind of radial cutting strategy will give you marking here. My suggestions, there's many ways to cut this part. The first suggestions is this one. Cut like this. And let's speed up. Right, so it should give you a very nice surface finish at overall, but you still have some problems over here. This place. Let's look at this place. So over here you might have some marking here. This cannot be avoided. If this area is not important, then it is okay. Let's look at the settings for this. So what I've done, yeah, surface tolerance for this kind of part no need to put so small. Most of the time 0.01 is enough. If you want to reduce, yeah, for me the minimum that I normally access is 0.03. Right, and let's go to assess this. So for this function, I'm actually using a flow line of the production flow lines, and because it's just a single surface, so just pick that surface to cut, and I'm using zigzag. Pitching's 1, and I'm setting the maximum 0.5, the minimum 0.25. The maximum must be 200% bigger than the minimum, right? So you need to use this setting here to control the minimum distance of the point to make it uniform. To do a sync if you want, if you need, you can do a sync, okay, to make it more uniform. Here, this is what I set, and I'm using stay normal to surface. and gouge check. As a standard, I always do a last gouge check to check the hole holders with the whole part to see any accretion or not, and also on this. Right. For the first gouge check, I'm actually checking against a dry surface, and the check surface will be the boundary surface, the red line. Yeah, that's my check. Right. So to check if there's any overcut, retract the tool along two axes onto the surface. For the linking, because this is zigzag, so it's pretty here, the linking over here, I'm using follow surface, follow surface, follow surface. Don't use direct. Direct will give you some overcut into the surface. Follow surface. That's it. This is the functions, right? So let me show you the point to point. Here. So you can see after I set control the point and sync the point, you can see the point to point distance is very uniform, and the grid is very uniform, right? Has been synchronized. So this kind of pattern should give you a very nice surface textures of the finish. And of course, beside this one, you can also do this, do a helical motions cut, right? But the helical motion cut will give you a problem over here. You have some marking at the tip here, right at the center. You have some marking. For other places, okay, right? So for this helicals, what I did is I'm using a parallel to curve and the edge curve. This is the edge curve. Right, this is edge curve, so I'm setting to parallel to that curve, and I'm doing a spiral cut, and of course I've done some point control also, and also over here yeah, option to choose. By default is approximate, so if you set 1 mm, the software try to calculate 1 mm, but most of the time not all the pitching is 1 mm, some may be 1, some 1.05, maybe 1.02, you know, something like that. If you want the exact 1 mm, then you can choose the exact. So in this setting, I just choose exact. Yeah, that's the result. Right, so this also will give you a very nice finishings compared to the radial cut pattern. And if you look at the navigator, if you look at the point should be nice also, right? It's also is uniform, very uniform, and it will give you a better surface finish. This file is online. Please check the link from the YouTube video to get this file.